Okay, you're welcome back to Integrated Thesis in Mathematics. Today I'm going to continue the previous session. This is the operating on the standard coordinate system. First of all, let me explain you what is it, what are the profits knowing the operating on the standard coordinate system. Okay, this would be pretty much usable when you are dealing with the standard coordinate system, and when you are when you're going to use the uh, divergence theorem and the curl theorem. uh, when you have electrical field or magnetic field, you need to use this when you're using the standard coordinate system. Okay, let me show you for example. You have this type of cylinder, or any of the shape that's gone in the cylindrical coordinate system. It could be a cone also. Okay, uh, and you have electrical field through this guy, and you need to use the uh, if you're gonna use the Gaussian laws, you need to know what's the del operator. Okay, otherwise you're not able to calculate this so far any of the evaluation so far during the evaluation. Okay, so if I explain so far, you'd have this type of Gaussian uh, equations. This surface class surface integral here is going to be equal to using the divergence theorem. You're able to allowed to write on the same thing, data dot the vector electric field dv. This it became just a volume integral. Okay, this would be a triple or double integral when you're gonna deal with the cylinder coordinate system. Okay, so there's a lag in my camera. Okay, I'm going to derive the del operator that's current cylinder coordinate system. So let me erase this. You need to know this, or any of the time you'll be able to derive these things, because actually no need to memorize all these things, no need to uh, recite all these things, because this is just mathematics. You need to go through this. Okay, otherwise you would not be able to it would not be worked on you. Okay, so you guys need to know how to do this. Please, if you don't understand, please be kind enough to put a comment or go to our videos. If you guys don't understand this session, please go back to our previous video sessions. Okay. So today we need to talk about the jar operator. First of all, I'm gonna write down this guy. Okay. Uh, Hope that you remember the cylinder coordinate system. This is a vector towards the uh, lying along an arbitrary direction. Okay, just like this. So the vector r can be written as this row. The vector r can be written as the vector rho plus vector z. Okay, it means that the magnitude of the vector rho times the vector that's lying along the rho direction plus z times the head. Okay, what I need to do is I need to find out dt. Let me show you why I'm finding out this. So, okay, so you need to use the using knowledge of calculus. Okay, this will be pretty much fantastic to you. Very, very fantastic exercise to you. Okay, so uh, rho times d rho hat plus rho hat times d rho plus z times dz hat plus z hat times dz. Okay, so uh, these you can see these two terms are they have preferred directions. This is along the direction. This is along the z direction. So these two terms uh, can be on. I'll put them here. This is okay. And the rest of these terms I put it here. Okay, we'll put this here. Uh, so this can be written uh, using the chain rule row times. Okay, pass row hat with respect to yeah row the row. Okay, uh, plus pass row hat with respect to phi times the phi plus partial row hat with respect to z times dz. Okay, this is just calculus. Okay, guys, the chain regarding the partial derivatives. Here this also can be written as z times partial row with respect to the row times the row plus partial z hat. Okay, uh, uh, it's like that. Partial z with respect to phi times dp plus you need to get the addition between these three terms. If you have more, you need to get the addition. Okay, uh, here z, this z. Okay, what about these six guys? Okay, let me show you. All these six guys are gonna come to the rest of rest of these terms. I need to put it for this guy here. Okay, that's why I put it here, because this is along the row direction and this is along the z direction. Why we need to find out what about the v direction also. uh, then only we are able to find out the dr. Okay, I'm gonna just break this into two sessions, because it will be it will take much time to derive this. Yes, I encourage you to go through this and continue. Just try to continue this. Okay. Uh, okay. Uh, Let me show you guys. What about these six guys? Okay. What about this guy? Yeah, partial row have with respect to. Let me just clear this out. Okay. Okay, partial row hand with respect to the row. We have, fortunately we don't have row times here. Okay, it means that it becomes, yeah, 0. Partial row hand with respect to phi. What about that? Partial row hand with respect to phi. When we are going to deal with the Jacobian metric, we have already found out this, just I recall all these things. Okay, when I'm gonna derive this, I need to do all these things. Okay, so this would be pretty much cool. Minus x hat sine phi plus y hat cos phi. Okay, what about this? This guy is going to be equal to this guy. It means that partial row hat with respect to phi means that this is just phi hat. Okay, let me use the color. This would be equal to phi hat times d phi. Okay, we see it very nice. Okay, partial row hat. What about the partial row hat with respect to z? Or here's the length. Okay, I'm worried about that because I'm using our primitive camera to draw it. Okay, partial row hat with respect to z. There's no z terms, so it becomes 0. Okay, we have only these terms. What about this guy? Partial z hat with respect to row. There's no row terms. This also is becoming 0. This one about this guy. This also is 0. What about this? Yeah, most of the guys are confused when you're coming at this moment. Okay, there's no z terms. We have only z hat. Okay, therefore this also is going to be equal to O. Okay, it means that we have only row head, the row plus row times. Here we have what about this guy? Yeah, this is along the head direction. Okay, that's why I write down it on this way. Row times dp. Okay, row times dp uh, plus the rest z times z hat times dz. Okay, keep it in your mind. Just I'm gonna clear out this how it's going on. Di is going to be equal to when you're gonna talk about this new coordinate system. Row head times d row plus free head times row times d free plus dc times dz. Sorry, dz times the head. That's lying along the z direction. Okay. Hope you would understand these things properly. Okay, let me show you how this is going on. Uh, uh, I'll, I'll show you what about the operator. What's the nice part to find out in the operator. Okay, and just I'm gonna stop it by there, and just I encourage you to do all these things with my next review session. I have to uh, complete this session. Okay, so you need to find out. You need to use the gradient theorem here. Okay, if you're going to think about the du, du can be written using the partial derivative, the general of the partial derivative, partial u respect to x times the x plus partial u with respect to y times dy plus partial u with respect to the z times dz. This is the next guy you need to use. Okay, and uh, the same thing can be written using the gradient theorem. If you know about the gradient theorem, this can be written by using the gradient theorem. This is our del operator del del u, because here we have u. Del u is going to be you need to get the dot product between these two guys. Okay, it becomes it became just scalar here. Okay, so here this can run on this way. Okay, this is the gradient theorem. Probably you know, if you know the gradient theorem, you're able to use this once you have this type of integrals. When you have a line integral, you're able to use the gradient theorem. It's pretty much easy to evaluate the line integral. Okay, electric field, or it could be a magnetic field, uh, any of the. Okay, so I'm gonna use these two conversions. Okay, these two expressions. Using these two expressions, you have already found out the vector dr here, and just substitute on this expression, and you have in the du term the term du using the partial derivative down in the general. Okay, and just substitute on this equation also, and you're able to figure out the operator. Just I encourage you to do this, complete this. If you have any of the doubt, please be kind enough to put your comments. Or cursor is still it's lying on this screen. I'm very sorry for that, because okay, so thanks for watching video. So um, uh, I wish to see you again in my next video session. Okay, thank you for watching.